Hi all, this is Team bitspace. So bitspace is an open source community. We contribute and collaborate with existing open source projects. So for this hackathon, Hackbox, we have developed a project known as TUSK. So TUSK stands for Trusted Utility for Statutory Knowledge. So what is TUSK actually? Let's consider a scenario. Say you're given with a documentation and you're asked to check the legality or validity of that particular documentation. So this particular task can be quite hectic considering the fact that the given documentation might even contain like around 100 to 150 pages of verbose content. So task actually makes this process much simpler by automating this task.
So first of all, we need to upload the regulatory documents. It may contain the policies or standards, whichever that will be forming our knowledge base. These documents can be of any format. It can be like scanned documents, type text, or even structured files, whichever one the organization prefers the most. So for the purpose of doing this, the users are provided with a React-based front-end through which they are able to upload the documents. These documents are then stored in Azure storage accounts, where we use Azure Document Intelligence to extract the text from the scanned copies. The text in this case can not only be extracted from the text contents, it can also be extracted from the images or whatever that is which is present in the document. The extracted content is now transformed into embeddings using Azure's text embedding tree large model from the OpenAI labs, and these embeddings are stored in Azure AI Search, creating an intelligent and searchable knowledge base. So now that we have created a knowledge base, the user must now be able to query whether a document that he has is valid or not. So for the purpose of doing this, again the user is able to upload a documentation, which is again stored in Azure storage accounts, similarly processed by using text extraction techniques through Azure Document Intelligence. So now that the extracted text is present with the user, it is then split into smaller parts, and this is where the magic happens actually. Each part undergoes a Retrieval-Augmented Generation, or RAG to be short. So after this, we use LangChain for prompt engineering, and each prompt is tailored with document content, relevant context from the knowledge base, and the previous validation results. After this, the Mistral tree model takes these as the parameters, and it validates the document section by section, giving us a detailed compliance results. So after all these steps, the results are then displayed in the front end, with each document section marked as either compliant or non-compliant, along with the reasons for each result, so that users can see exactly where the document stands in relation to the company's compliance standards.
So this is how TUSK actually works. So let's move on to the architecture part now. So this image basically sums up the entire architecture of our application. However, the entire implementation is based upon Azure services, and if it wasn't for Azure services, the basic implementation would have been really difficult. We wouldn't have even gotten through half of the development part without Azure services, if I could say. Okay, so first of all, the documents which are being uploaded by the users, they are being analyzed with other services, for example, Document Intelligence and Azure OpenAI. So what this does is that it just effectively extracts every single content from that particular document, not just the text content, any other content, not only just the text, even the images and stuff. It just extracts everything from it, and then whatever output it contains, it is then stored towards a vector database. And from that vector database, every time the user queries a new documentation asking whether it is valid or not, what it does is that it performs a similarity search in that particular vector database. So for the storage of the files, we have used Azure storage accounts, and Mistral is a model which checks for the similarity. The embeddings are created based upon the OCR recognition, which is provided by the document intelligence model. And for the backend part, we have used Flash services in order to easily communicate with the backend. And for the deployment of the backend part, we have used Azure Container Apps. So what we have done is basically we have containerized the entire backend so that it is replicatable on any machine that we want it to be replicated upon. So that's it for our presentation. Thank you very much for watching.